CBSE Class 10 Math Sample Question Paper, year 2020, question number 28. It's a 3-mark question from Arithmetic Progression. The question is a very algebra-intensive question. If the sum of the first m terms of an arithmetic progression is the same as the sum of its first n terms, obviously the understanding is m is not equal to n. If m is equal to n, obviously it's going to be the same. Show that the sum of its first m plus n terms is 0. That's what we need to prove. Sum of the first m terms, sum of the first n terms. Before that, let's assign the usual two variables. The first term of this AP, let it be a, and the common difference of this AP, let it be d. Sum of the first m terms is m by 2 into 2a plus m minus 1 into d. Sum of the first n terms is n by 2 into 2a plus n minus 1 into d. They're essentially saying these two are equal. So let's do that. M by 2. I'm going to deconstruct it into every single broken step. You can skip some of these steps actually in the examination. For writing this, you'll get 1 mark. Right? Let's move on and see when will you get the second mark. M by 2 into 2a plus m minus 1 times d. This is equal to n by 2 into 2a plus n minus 1 times d. Multiply both sides with the 2. The 2 gets cancelled with 2. I'm going to take this 2an term to the left hand side. I'll expand this, which is going to make it as 2am plus m times m minus 1 times d. This is equal to 2an plus n times n minus 1 times d. Actually, what I'm going to do is I'm going to take all these terms to one side. So we take this 2an to the left hand side by taking 2a as a common term. So we'll have 2a times m minus n. So I've accounted for these two. Now let's take d common outside. If I take d common outside and expand the terms I'm writing, m square minus m is what will be here. We would have got this minus of n into n minus 1 to the left hand side. It would have become minus n into n minus 1, which will make it as minus n square plus n. This is equal to 0. We've taken all terms to the left hand side. Let's club the like terms together. M square minus n square, power 2 and m and n. So what we'll get is 2a times m minus n plus d into m square minus n square. We can write it as an m plus n times m minus n. We're going to take minus common outside. So minus of m minus n is what this will be, which makes it as minus m plus n. This entire thing is equal to 0. M minus n term here, m minus n term here, m minus n term here. So let's take that common outside. So you'll have m minus n. We'll open a curly braces. We'll have a 2a from this part, 2a plus there's an m plus n and a 1. So m plus n minus 1 into d, that is equal to 0. So taking m minus 1 n common. So you'll be left with a d into m plus n minus 1. This is equal to 0. We know that m is not equal to n. If m is equal to n, obviously the sum of the first m terms will be equal to sum of the n terms. Which means that if m is not equal to n, m minus n is not equal to 0. This part is not equal to 0. The product is 0. Which means that this part should be equal to 0. So we can infer 2a plus m plus n minus 1 times d equals 0. The moment you reach this part, you're going to get the second mark. What is the sum of the first m plus n terms? The formula is sum of the first m plus n terms is equal to m plus n upon 2 into 2a plus m minus 1 times d. Do you see the same thing here? We just established that 2a plus m plus n minus 1 times d equals 0. So this part is equal to a 0. This entire product is going to be equal to 0, which means sum of the first m plus n terms equals 0, which is what we have to prove. Quickly run through this entire thing in a printed form. Sum of the first m terms is equal to sum of the first n terms. Multiply both sides by 2 and expand the terms. So you'll have 2am plus md into m minus n, 2an plus n into d into n minus 1. Take all terms to one side. So 2am minus 2an, m minus 1 times md minus n minus 1 times nd. Take 2a common outside. So you'll have this part becoming 2a times m minus n. Take d common outside from these two parts. So m minus 1 times n minus n minus 1 times n. Expand both these expressions. You'll have m square minus m minus n square plus n. This part remains as it is. We're clubbing these two terms. So 2a times m minus n plus d into m square minus n square minus of m minus n. The next step, we're going to rewrite this m square minus n square as an m plus n into m minus n. We have an m minus n term, m minus n term, m minus n term. So 3 parts are there. We got an m minus n common to all those parts. So let's take that m minus n common outside. We left with the 2a from this part. D times m plus n minus 1 equals 0. m is not equal to n, which means m minus 9 is not equal to 0. If this entire product is 0, that leaves us with this part to be a 0. So we established 2a plus d into m plus n minus 1 equals 0. What's the sum of the m plus n plus n terms? First m plus n terms. M plus n by 2 into 2a plus n minus 1 into d is what it has said. Here it is m plus n minus 1 times d. We just established this to be a 0. So this portion is 0. The product should be 0, which in sum of the first m plus n terms is equal to 0. Before you leave, do two things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. It takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.